Hello and welcome. I seem to be having some technical troubles with my video recording at the moment, which means two things. One, you're not going to see my smiling face down in the corner like usual, and two, this is like my third attempt to record this video, and I'm getting really fed up of it, so you're going to get the fast-talking, rather more terse than usual version, which maybe you'll like it. That's how I like my videos anyway. All right, so a couple of videos back, I talked about a situation like this where you had an array of arrays, meaning, there was some function you applied to each row of a table that generated arrays of different sizes, all anchored in the same column. So in this case, we wanted to turn this 1001 to 1010, 10 tickets, into a list of 10 tickets that went out 10 columns. Here it goes out 5, here it goes out 16, and so on. The challenge at the time was, given this array anchored in a column, how can I refer to the whole block that contains them all, and found some interesting tricks to do that. But it also begged the question, this doesn't seem like the greatest way to produce this array. If it's going to be really hard to refer to, how could you produce it in a more dynamic way? Both so that, if this data here changes and this becomes 17 columns, it expands, but also so that if another name is added at the bottom here, it expands as well, which right now it doesn't. You'd have to copy it down. So, you're missing some of the benefits of dynamic arrays. A couple of other examples where this might apply. Here, the example from the Excel challenge I gave recently, which I haven't forgotten about, and will have the solution video out too soon after I've finished re-recording this. Who knows how many more times to get it to work. You have a list of 60 nodes and which nodes each one of them is connected to. You can use TEXTSPLIT to split that into a list of nodes for each one. But if you try to apply TEXTSPLIT to the entire column, then it will only give you the first one from each one, because TEXTSPLIT doesn't want to take an array of arguments. That's just not what it's set up for. One person also told me they tried to use a by-row. By-row just says apply a function to each row of a table. In this case, the function that splits text by comma and space, and stacks them all on top of each other and returns that. But as you can see, that gives a calc error. By-row only wants to return one value per row, and if you look at the error here, it says nested arrays are not supported. Nested arrays being exactly this kind of thing where, there's like an array of arrays. So that's that. This one over here, just to mention, behaves in the same way. If I try to just refer to, take the same formula and refer to a whole range, which, works well for a lot of dynamic array things, but again, here it just returns the first value from each one. It doesn't behave the way you want it to. Two other quick examples, then we'll talk about solutions. Here you've got a table of employees, their teams, their regions, and their revenues. Here you've got a list of employees that you want to look up some information for. There are a couple of ways you can do XLOOKUP more flexibly than you could do lookups before. One is you can look up this name and return 3 columns all in one, team, region, and revenue. So you only need one formula per row. You can also look up a whole block of names and return 1 column, so that you only need 1 formula per column. But if you try to combine those two in what feels to me like a kind of logical way, it doesn't like that. So I'm saying look up all of these names in this column and return the corresponding entries from these 3 columns, and it's saying no, same thing again, it's only giving you back the first column. And then last example, someone asked me about this in the comments a little while back. Say you have a table like this and you want to sort each row in ascending order. So again, it's easy to do that line by line. You just use the sort function, and the optional last argument is do you want to sort by column? You put in true there and it sorts across instead of up and down. But again, if you apply sort to the entire table, it just by default sorts by the first row. So this is now in ascending order, but this is not, and this is not, and this is not, and so on. So that doesn't give you the desired outcome. So I'm going to show you two sort of specific tricks that work for specific ones of these situations. Then I'll show you a couple of more general things. Specific trick number 1, for the lookup situation, you can handle it with an index and 2 X matches. So here you're saying index on this block here. The rows are what you get by matching this against the list of names, and the columns are what you get by matching this against the list of headers. And one nice thing about this is if you want to rearrange the columns, it's easy to do that, which here with the with the across the row XLOOKUP, you're dependent on these being in the same order as in the original data, or you'd have to do something to rejig them. So that's kind of nice, but yeah, I'm sort of hoping that this kind of two-dimensional use of XLOOKUP will get supported at some later point. But anyway, it's not supported right now. So that's one. Second thing, Wyn Hopkins showed a nice little trick in a video a while back, which I'll put a link to if I remember, for how to make TEXTSPLIT take a whole column. And the idea is just first you join the whole column. Sorry, I always forget that text join. The first argument has to be the delimiter. So let's say you join it on a semicolon, just has to be some different delimiter than you're using to split the columns. Take that whole column. Now you have one big thing, and then you can apply TEXTSPLIT to that using both row and column delimiters. So I'm going to split the column by comma space, same as before, but now the optional third argument, I'm going to split the rows based on a semicolon. And now you get this. And again, one thing you'll see with a lot of these dynamic solutions is, where you're outside the range of values, there's still got to be something there, and it tends to be some kind of error. So in this case, you might want to wrap it in an if NA to say, give me blanks for those, or you might not. If you're going to, for example, if you were going to wrap this in a two-col, then you might prefer to have arrays there, because then you can, arrays to have errors there, because then you can say ignore errors, save you a step. Anyway, so that's the second specific trick. Then the slightly more general trick here is to use MAKEARRAY. I'm going to get rid of the one I made earlier because I prefer to build live. And MAKEARRAY basically just says, well, it does exactly what it says on the tin. It says make an array with a certain number of rows, certain number of columns, and then a function to define what goes in there. So I'm just going to use a let. I'm going to define the data here because I'm going to be referring to it a few times. So that's my data. Then I'm going to say MAKEARRAY. So the number of rows is going to be the number of rows in the data, and the number of columns is going to be the number of columns in the data. I'm not changing rows or columns, I'm just rearranging things within it. And then the function is always going to be a function of the row and the column. And then it's, what value do you return for a given row and column. So in this case, if I'm in row 1, then I'm interested in operating on this. So we're going to take index data R. Then we're going to want to sort that. And again, we're going to want to sort it by column. So just last argument is true. And then once we've sorted it, in the first column, I want to take the first value from that sorted list, second column, second value, and so on. So I just wrap that in index, comma C, and then close, 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 close. And there you see it reproduces this. But now, if I add more values here, say 724, now this expands in a way that this doesn't. Downside of MAKEARRAY is you do need to know the size of the array before you do it, which with this one, for example, you won't by default. So here we can do this one with MAKEARRAY. So we're just going to say rows of this. And for now, let's just say we want 4 columns, and I'll come back to that in a minute. Then again, lambda RC, it's a function of the row and the column. So I'm going to index on this, comma R in that row, and then I want to TEXTSPLIT. And sorry, I'm not going to get into why, because this video is otherwise going to be too long, but I'm going to put a comma 1 there because sometimes with arrays you apparently need to be more specific than just a 1 argument index. It helps to give 2 arguments, because then it understands that it's just a value and not an array. It's a little complicated and technical. Like I said, not going to get into it now. TEXTSPLIT that by comma space, and then we're going to index on that, comma C, and then close, 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 and that gives me exactly what I want, except that here I've got 5 nodes and it's only going out as far as 4. So it's pretty easy to kind of do a manual check if your data isn't changing. You could, do it for some large number of columns and then just check here. Okay, that's all ref. So, there's nothing in the 6th column. There's some data there, so I only need 5 columns. But if your data is changing, let's say we're going to add an A, I'm going to add a B. This does not expand, so that doesn't work. So basically with MAKEARRAY, you'll need some way to figure out for a situation like this, it's ideal because it's, you're just rearranging, it's always the same number of columns by default. Again, you could use MAKEARRAY very neatly here because it's always the same number of columns. For a situation like this, you're going to need a way to figure out in advance the greatest number of columns that you're going to have. So for this case, you can use a little trick, and that is, if you want to figure out how many items is in each of these lists, well, you can figure out how many columns is keep mixing up column and comma today for some reason. How many commas is in the string? A handy way to do that is to take the length of the string and subtract the length of the string that you get if you take the commas out. So replace the commas with blank using substitute. The difference of those lengths is 1, meaning there's 1 comma. 1 comma means there's 2 items in the list because there's 1 fewer commas than items in the list. And then this is a function that works nicely with full arrays. So I just delete those ats to get the full column. Gives me that. And then I can wrap that in a max, and that'll tell me the largest number of columns. And then again, if I go back here and add an A and add a B, that immediately goes up to 7, all behaving nicely. So then I can just take this and drop it into my MAKEARRAY. But again, now we're back in the land of specific tricks. This only works because I have a neat trick to work out in advance how many columns there's going to be. A more general solution would be to take a by row, and then for each row apply whatever function you're figuring. So like apply the text split in this case, or apply the sequence in this case, and figure out how many columns that's producing, and then just return that number of columns, and then use the by row to get the full list, and then take a max of that. The challenge with that is you're then basically kind of doing your whole set of calculations twice, once to figure out how many columns, and then again having figured out that many columns to do the MAKEARRAY. So the last option is more flexible. Now I'm going to do the 1-minute version of the tutorial here. The last option uses the reduce function. I'm going to quickly introduce you to scan and reduce. They're a sort of natural pair. The idea is they're for any situation where your the running total is the classic example, right? So in this case, I've got this input data here, and then using a formula, I'm coming up with a running total. And you've almost certainly done this before. So, you might start with a different formula in the first row of just that, or you could, if you have a blank row above, then you can just say equals the row above plus the current row, and then you just keep adding the current row to everything you've built up so far. The key thing is that at any stage, your value here is only a function of everything you've accumulated so far and the current value. So that one there and that one there. And scan basically turns that into a dynamic array. So it says, give me a starting value, give me a series of values to feed in one by one, which is these, and then tell me what function to apply to A. Think of A for accumulate, what you've accumulated so far, and V for value. V is the new value. I got this naming convention from Bo, but I find Bo Ridabon, also known as Excel Wizard, who is a genius of scan, reduce, and all the other Lambda helper functions, as well as Excel in general. But like I said, I find it pretty intuitive. This is what you've accumulated, this is the new value, and then what do you apply to them? In this case, you just add them together. In this case here, where we're putting a new letter at the start of the previous string, it's just concatenation. So scan, as you can see, builds up a column of those running totals just like this here as a dynamic array. Reduce does basically the same thing. It's all the same syntax. As you can see here, I just replaced the word scan with the word reduce, and the only difference is instead of giving me a column or a row or a block, depending on how you set it up, reduce just gives me the final value. So same thing here, reduce just gives the final value. The slightly weird thing is, like I mentioned earlier, how by row only wants to give a single value per input. Scan only wants to return an array that's the exact same dimensions as the input array. So it does not want to output 2 columns for this one, and 2 columns for this one, and 3 columns for this one, and 1 column for this one, or even just 2 columns for every one of them. It only wants 1 output per cell in the input range in the exact same shape. Reduce, because it's only returning 1 value, can be more flexible. So that value can be an array It can be all kinds of things. And what that means is you can use reduce, what I call a growing reduce, because it's, it's the name is slightly misleading. Reduce, it's called reduce because it reduces down to one value, but you can make your reduce grow in a way that you can't with scan. So first of all, you can just reproduce what scan does with a growing reduce. And the idea is just instead of instead of just saying take the old value and append it to what you've accumulated so far, you say VStack everything you've accumulated so far, so all the values so far, and then at the bottom of that put the current value ampersand, and then take from a -1 just means take the last value. So in other words, you're building up this stack of values. You take the last value, append the new letter to that, and then you put it at the bottom of the stack. So the stack keeps growing. The one thing is, when you do reduce in this way, it also returns the initial value. Sometimes you can just leave that blank, like in this case, and it'll behave appropriately. Sometimes if there's not a first input, it'll get confused. So the more general solution here is just to wrap that in drop so that you drop the first row. But either way, you can see that reduce then reproduces what scan does. Very briefly, reduce also lets you, so scan can only ever look at everything you've accumulated so far and the current value. So something like the Fibonacci sequence where you always sum the previous two values, scan can't do, but reduce can. So in this case, reduce is just returning for any given input. So, step 1, step 2, step 3, it's returning two consecutive values of the Fibonacci sequence. And then the function that takes you from one of those to the next is you stack the second element from the last array. So take -1 means take the second element, and then you sum the last two elements to give the second value. And again, just like, so you can make this give you the 10th and 11th Fibonacci numbers like that, or if you just drop the take here, you can also make it give you the whole list of them. But anyway, like I said, the key thing is its ability to grow. So now let's come back to this original function, and I'll show you how to do it with a reduce. Now the additional complexity for this one compared to, say, this one is here you're only operating on one column. Here you're operating on two columns. You're interested in the number of tickets and getting the starting point from here. So I'm going to, again, start from whatever value you want. Rather than giving it an array like this or an array like this, I'm going to give it an array of row numbers and then use that to refer to each one of these. So I'm going to say sequence rows. I'll just give it the table. And then, again, what's the function that I'm applying to what I've accumulated and the value? Well, first we're just going to VStack, put everything we've built up so far on top, and then what are we going to put on the bottom? On the bottom, we're going to put the new sequence that we get here. So that is sequence. So the number of rows, well, we want it to output across a column, so the number of rows we can leave blank. The number of columns is this here. So again, V is going to first be 1, then be 2, then be 3, then be 4, then be 5, then be 6. So when V is 1, we're interested in these values. So we're going to say index on this V1, and then so that's how many columns. And then where do we start? We start at the start of this, and that is text before index of this V1. I want what's before that. I'm going to multiply it by 1. I don't know if I need to, but just to be safe. So that finishes the VStack, finishes the lambda, finishes the reduce. And that gives me basically what I want, although it looks very messy right now. A couple of things to note. One, as before, we've got kind of errors here. We can deal with that by wrapping it in an if-NA. And the second thing is, actually it's easier to see it if I leave the NAs there. We've got the initial value here. First first thing, like I said, sometimes leaving the initial value blank will get it to behave the way you want, but in this case it doesn't. Now it's just giving me a 1. I don't even honestly completely understand why it is doing that. I think, well, I don't know why. So instead of doing that, I'm just going to drop, comma, 1. Drop the first one and then wrap that all in an if NA. And that is your general solution to trying to build an array. So basically this function here inside the VStack, inside the lambda, inside the reduce, inside the drop, inside the if NA is the only thing that you need to change. This is the thing that says, you know, basically produce one value, and it doesn't have to be a row. So, I mean, just as a quick kind of example, if I said each of these was going to be two rows instead of one, it doesn't mind that at all. So now this is the output of the first row, this is the output of the second row, this is the output of the third row, or it could be a variable number of rows. It doesn't mind at all. Or equally, I could swap that from being the swap this here from being the number of columns to being the number of rows, so that it stacks them vertically, and we get it like that. It doesn't. It's very, very flexible about the shape of each step along the way. So you just need to tell it basically what to do with each row, and using this index setup here, if you just make your argument be 1 to 6 where there's 6 columns using sequence rows, then again you get that flexibility as well. If this seems easy for you and you want to take it to the next level, check out Owen Price's very cool video, which again I'll put a link in the comments if I remember, in the video description, sorry, where he shows you how to basically abstract this whole pattern and make a simple stacker function that takes an array input and takes a function and applies that function to each either row or column in the array, and then stacks the outputs. So it kind of generalizes this very nicely. All right, that's all I've got for today. Hoping my video recording woes will be behind me soon. Thanks for watching, and I'll see you next time.